Hi students, in this video I'll be going through the 2023 A Math paper 2 question 9. Alright, so this is the last question in the paper. Alright, let's read the question. Okay, the diagram below shows rough level ground that is shaded, okay, bordered by a straight level road BXA. So the shaded part of the diagram represents the rough ground, and then this straight line BXA, right, is actually a straight road, okay. So point C is on the rough ground and B is on the road closest to C. Okay, so whenever they say B is closest to C, right, that means this angle has got to be 90 degrees already. Okay, so this is looking from the top view lah. Okay, but based on this diagram, that means B is vertically below point C. Okay, point B is vertically below point C. All right. So the distance AB is 15 kilometer and BC is 8 kilometers. Okay, a cross-country runner is at point A on the road and needs to get to point C as quickly as possible. So the cross-country runner wants to run from here over here and wants to do so as quickly as possible. So on the straight road, he can maintain a speed of 5 kilometers per hour. That means when he's running from, let's say, point A to X, right? Okay, the speed that he can maintain is 5 km per hour. Okay, but only 3 km per hour over the rough ground. So if he's running along the rough ground or any part of the rough ground, then his speed is only 3 km per hour. Okay, so the runner realizes that in order to minimize the total time to get from point A to C, right, he cannot run from point A to B and then B to C. He won't be able to make it there in the fastest possible time. So he needs to run from A to X, okay, and then at this point X, he needs to leave the road and then move into the rough ground to go directly towards C, right? Okay, so remember that the speed along the rough ground will be 3 km per hour. Okay, okay, so let AX be X. Okay, so if AX is X, right, and AB is 15, then what can we say about XB? Okay, so XB should be 15 minus X, right? Okay, and T be the total time in hours taken by a runner to get from A to X and then from X to C. Okay, so they want us to show that T, the total time taken, right, to run from A to X, then from X to C, is given by this expression. Okay, so such questions look very difficult, but actually it's not really that difficult. Okay, so you just have to break it up and then do it part by part. Okay, so let's take a look over here. Okay, do you recall the formula that relates distance, speed, and time? Okay, so time will be equals to distance, okay, divided by the speed, right? Okay, so time is distance divided by speed. Okay, so can we calculate first? Okay, the time it will take to run from A to X. Okay, so let's do that. So time to run from A to X. Okay, so the time to run from A to X will be distance X kilometer, okay, divided by the speed, okay, 5 kilometers per hour. Okay, so that will give us X over 5 hours. Okay, right. So now we just need to calculate the time it takes to run from X to C, and then we add both time together, we'll get this big T already. Okay, so that's what we should try to do. Okay, but okay, we know the speed from X to C, but we don't know the distance. Okay, but BCX is a right angle triangle, right? So we can actually use Pythagoras theorem to find XC, and then once we find XC, then we can find the time taken, right? Okay, so let's do that. Okay, so using Pythagoras theorem, so using Pythagoras theorem, okay, XC square. Okay, so if you want to refer that, when XC square will be BX, okay, which is 15 minus X square. 15 minus X square plus CB, okay, plus BC, okay, 8 square. Okay, so let's expand this one out first. Remember, 15 minus X square, you got to expand it this way, okay, using rainbow method. You'll get this plus X square, then you'll get 64. Okay, so we'll rearrange. Okay, 225 plus 64, you will get your 289. Okay, that's why there's a 289 over here. Okay, so this xt square. So xt you just square root this thing. Okay, so this will be xt. Okay, so to calculate the time, okay, time to run from x to c, okay, will just be the distance, okay, divided by the speed, okay, which is 3. Okay, so actually we have already gotten the answer. See, this x minus 5 comes from the first part, and then this one is the second part, okay? Second part of what they want us to show. Okay, so therefore, t equals to x over 5, okay? The time taken to run from a to x over 5, plus the time taken to run from x to c. Okay, so this will be the time taken, right? So we show already. Right, let's move on. Okay, so the question is actually not as difficult as it looks. Okay, so it's actually rather straightforward. Okay, so to give such questions a chance, when you see such questions, don't be afraid and then skip the question. Okay, so take your time to read through and you should be able to do it. Okay, let's take a look at part B. Okay, find an expression for dt dx and hence show that the value of x for which the time taken is a minimum satisfies the equation x squared minus 30x plus y9 equals to 0. Okay, so what they want us to do now, okay, actually you just have to follow instruction. The first part they want us to find dt dx. All right, so what we need to do is differentiate t. Okay, so t is okay, what we shown in the first part, right? Okay, even if you are not able to show you can still continue to use it and then do this part B of the question. Okay. Okay, so to prepare for differentiation, we'll put it in this form. Okay, so x over 5 is 1/5 x. Okay, so this will be 1/3. Okay, square root means power half, right? Okay, square root means power half. Okay, so once you put in this form, then we can differentiate. So dt dx. Okay, differentiate 1/5 x, you get 1/5. Okay, this one we'll use the chain rule. Okay, so we'll bring the power down first. Okay, so 1/3 times half. Okay, so I'll put the half here. Okay, half go in front. Okay, reduce the power by 1. Okay, so half minus 1, you get negative half. Then differentiate the inside. Okay, so differentiate inside the bracket, you get negative 2x plus 30. Okay, so we'll simplify a bit. Okay, so you will get 1/6 here. Okay, I'll put the 2x minus 30. Okay, we can just leave it like that first. Okay, so we get 1/6. Okay, we'll just leave it here. We'll do extra step. Okay, so we'll get this. Okay, so we'll put the 2x minus 30 on top. Okay, the 1/6 goes below. Okay, we want positive power, so we bring this x squared minus 30x plus 289 power negative half down, so it becomes power half. Okay, power half is a square root, so we will get this. Okay, okay, but over here at the top, we can actually factorize out 2, right? Okay, so we can actually take out the 2. Okay, then simplify with the 6. So you can achieve like that. Okay. Okay, so one more step. Okay, so if you are more familiar, you can actually skip some steps. But over here, I'm just trying to show the full working. Okay, so you get your answer for the first part. So this is dt dx, right? Okay, there's a 3 over here. Okay, so it is 2 divided by 6. Okay, so there's a 3 over here. Okay, so what did they want you to find? They want us to show that the value of x for which the time taken. So the time taken is the t, right? Okay, so when t is a minimum, right? Okay, what can we say about dt dx? Okay, dt dx is the gradient for the function, okay, the time function with respect to x. So if t is a minimum, then dt dx is equals to 0. Okay, so that's basically what we want to do. Okay, I'll do the working at this side. So at minimum t, dt dx equals to 0. Okay, so we'll put the dt dx equals 0. So 1/5, okay, plus x minus 15 over 3 square root x square minus 30x plus 289, okay, equals to 0. Okay, so to solve this, we'll bring the whole of this term to the right side. Then we'll do cross multiply. Okay, okay, so we'll do this. Okay, then we will do cross multiplication, cross multiply. Okay, so we will just cross multiply. Okay, the negative sign, either you leave it on the top or you leave it at the bottom. Right? So in this case, I'll leave it. I'll follow this one. Okay, to go the other side. Okay, so you get negative 3 square root x square minus 30x plus 289. Okay, then since the negative sign is follow the bottom, right? Then the top, this 5 just cross up. So just multiply, you get this, right? Okay, then to solve this, we will just square both sides. Okay, so we will just square everything like that. Okay, so if you square this, square negative 3, you get 9. Okay, you square the square root term is gone. Okay, then you square this. Okay, you square 5, you get 25. Then you have x minus 15 square. Okay, so x minus 15 square, if you expand out, you get x square minus 30x plus 225, right? Okay, so over here, this one, what we are doing is x minus 15 square, right? Okay, so we're going to expand out everything. Okay, so there's a bracket here. So you get 9x square minus 270x. Okay, 289 times 9, you get 2601. Okay, over here you get 25x square minus 750x plus 5625. Okay, so if you bring everything to the right side, okay, 25 square minus 9 square gets 16x square. Okay, minus 70 minus 750x plus 270x minus 480x. Okay, then 5625 minus 2601, you get 3024. Okay, then from here to get what they want us to show. Okay, remember they want us to show this x squared. So it's x squared coefficient is 1, right? Here is 16. So we should suspect that you need to divide by 16. And hopefully the rest of the things fall in place. Okay, so if you take 16x squared, divide by 16, you get x squared. Negative 480 divided by 16, yeah. Negative 30. 3024 divided by 16, yeah. 189. Okay, so we are able to show what they want us to show. Okay, so let's write on the left side. Okay, so shown already. Right, any question? Okay, so this is good. Okay, so this question a bit long. Okay, but actually it's long because I showed every step now. Okay, so if you are familiar, you should be able to skip a couple of steps. Okay, but do be careful, don't make mistakes. Okay, part C, hence find the minimum time taken in hours and minutes for a runner to get from A to C. You're not required to justify that this time is a minimum. Okay, so basically what we need to do is we just need to solve this equation to find the distance x, right? Okay, and then after that we will just sub back inside this one and then calculate out what is the minimum time, right? So let's solve that. Okay, because remember this x that we get will be the x that gives the minimum timing, all right? So factorize this, okay? So x you will get minus 9 minus 21, right? So either x minus 9 equal to 0, x equal to 9, or x minus 21 is 0, x equals to 21. Okay, okay, so we got to reject x equals 21 because if you look at the diagram, okay, AB is only 15 only, so x cannot be more than 15, right? So we'll reject this 21, okay, because x should be less than 15 now, okay? So we will use 9, okay, so minimum T occurs when x equals to 9, okay, therefore minimum T equals to, okay, so we have sub 9 inside the expression for T, okay, which is we found in part A. So you will get 9 over 5 plus square root 9 squared minus 30 times 9 plus 289 over 3. Right, so if you calculate out this one, you get 9 over 5. Okay, so at the top, if you calculate out, you will just get 10. Okay. Okay, that means 9 squared minus 30 times 9 plus 29, you will get 100. Square root 100, you get 10. You get 10 over 3. Okay, if you calculate this together, okay, they want in hours and minutes, right? So you will get 5.1333 hours. So it will be 5 hours. Then 0.133 hours, right? Okay, so okay, just take 0.1333 times 60 minutes. Okay, you will get the time in minutes already. Okay, so you will get 8 minutes. Right, so this the last question for this 2023 paper 2. Okay, so it's also a maxima and minima problem. Okay, so I'm not sure why the paper has two maxima and minima problems in question 8 as well as question 9. Okay, but as you can see, the questions look difficult, but actually it's not really that difficult. Okay, so do give it a try.